This is question number 6 of homework 5 for chapter 5. So you're given 3 investment alternatives. To analyze the cash flows from these 3 investments are shown in the pop-up window. Assuming a discount rate of 21%, find the present value of each investment. So what's convenient about the current version of MyNav is that you can actually click on the following icon in order to copy its contents into a spreadsheet. So that makes the calculation far more easier than before, that we can only use probably calculators and input the numbers manually, or even if we use Excel, then we have to find a way to copy, or maybe just input numbers also manually into Excel. So now it's much easier to do. So let me click on the icon and open in Excel, and we'll find out. So investment A, this is relatively easier to do because obviously this is a annuity, right? So we can calculate the present value of annuity very easily. It's just equals PV and open that. And we are told the discount rate is, if I remember that correctly, that's 21%. And NPER refers to the number of annuity payments. Here it's 5, right? 5. And after that, it's a PMT, that's the payment. So payment is just right here. And the rule to use Excel or a financial calculator is that if we keep the payment as positive as it is, then we're going to get a negative present value. So if we want to get a positive present value, and then we can add a negative sign in front of this cell value. So, and then after that, the future value, there's no future value. This refers to some future lump sum, cash flow, and type. We don't have to worry about type. Here it refers to the type refers to whether it's beginning of the year convention or end of the year convention. By that we mean whether the cash flows occur at the beginning of the year or by the end of the year. By default, all the cash flows occur by the end of the year. So that's what this year number here refers. Year 1 means that the cash flow $11,000 will occur by the end of year 1. So that's what this year 1 cash flows mean. So by default, it's this end of the year convention. And we can close that. So, and then go back to the setup and find out the rounding requirement, round to the nearest cent. I believe that's what we already did. If not, then we can just round this to the 2 decimal places, and then that will follow this requirement. And then we can just copy the number back. And then don't forget to get rid of the dollar sign. I believe we can keep the comma sign here. It's acceptable by lab. And check my answer. And continue that for B. So what's different about B is that it looks like a annuity, because every year the cash flow are the same, but by every year we're actually ignoring year 1 through year 4, right? All these 4 years there's no cash flow. So strictly speaking, this is not a annuity, because annuity requires every year to have the same cash flow, such as an investment A. But investment B, only year 5 through to year 10 has constant cash flow, but year 1 through year 4 there's zero cash flow. But that doesn't mean that we cannot use a strategy that can take advantage of the present value formula for the annuity to work out the solution for this investment. What that means is that we need to be reminded the formula for the present value of annuity here refers to a present value 1 year before the first annuity payment. So what that means is that if we want to use the annuity formula to calculate the present value, then we need to remember that the present value we're calculating for investment B here actually is referring to the present value at year 4, because relative to year 4, year 5 becomes year 1, right? Similar to investment A, what we are actually calculating is year 0. It's the point we are standing here. So year 1 becomes 1 year later. So that's and then we can use the present value formula to calculate the present value of investment A. So, and then similar to that, if we want to use the formula for the present value to calculate this present value of this annuity, then we need to remember that this present value actually is referring to year 4. It's not strictly at year 0 yet. So in order to calculate the present value of year of investment B, now we can follow 2 steps. One is to calculate present value in terms of year 4. And we can use the similar procedure as we did earlier for investment A to do this calculation, right? It's just the present value, and then the rate is 21%, and then just count the number of annuity payments, and this is 6. So input 6, and payment. Again, we add negative sign in front of the cash flow here, just because we want to get a positive present value. But then remember, this is present value of year 4. So we're not done yet, because our goal is to get present value of year 0, or the true present value. But after that, once we get the present value in terms of year 4, just remember that relative to the true present, which is year 0, now year 4 becomes the future. So now we just need to discount this number further back by how many years? By 4 years, right? Because this is year 4. By 4 years to get the present value of this number. So that means we can use again this PV function and open it. Again, this interest rate or the discount rate is the same, 21%. And now the NPER is no longer referring to the number of annuity payments. It's referring to the time period where the future lump sum cash flow occurs. Now it's year 4, so we just put a number year 4 there. And payment, this is no longer an annuity, so the payment here is 0. But now we need to put a future value, because as we said, relative to time 0, year 4 becomes the future. So the present value in terms of year 4 becomes the future value. And again, because we want to get a positive present value, we add a negative sign in front of this of this number. So just put that and then type. We don't have to worry about that. So just put this number. So this becomes the true present value of this semi annuity. But as we discussed, this is not a true annuity. But we have sort of used at least one of the steps, right? Used the present value formula for the annuity to figure out the answer. I think this is a shortcut. And another way to get probably the same answer is simply to use what we talk about in class, the present value of an uneven stream of cash flows. I will just find out that where is that formula? It's right here. So present value of an uneven stream of cash flows. The reason why, strictly speaking, investment B has uneven stream of cash flows is because, as we said, not every year's cash flows are the same. So that doesn't meet the requirement for to be an annuity. So we can use this most general way to figure out the present value of investment B. to use the present value of an uneven stream of cash flows. But this has far more complications compared with the steps we followed in order to figure out the answer. Right? How do we use the present value of uneven stream of cash flows to figure out the answer? I think we can just use the calculate the present value of year 5's cash flow, right? It's $11,000, and then calculate the present value of year 6 cash flow. Again, it's $11,000, and then calculate the present value of year 7's cash flow, and so on and so forth until year 10's cash flow, and then add them up. So that's another way to get the same answer. But you can imagine this is more complicated than what we just did. So now I can check my answer. And finally, what is the present value of investment C? So PV of C. C is, I don't think there's any shortcut for C because you can see that every year's cash flows are different. So, and then we can probably only use the present value of an uneven stream of cash flows to figure out the answer. So we can use, we can calculate the present value of this $11,000 at year 1, right? And then add present value of this $55,000 at year 2, and then add present value of this $11,000 at year 10. Actually, this $55,000 is not at year 2, it's at year 6, right? We need to keep that in mind. So that's the formula to get to the present value of the investment C. And then the rest of the job is simply to get each of these 3 present values. So that equals present value, and then open that 21%. And then for the first cash flow, it's year 1, so just put year 1 there. And then the payment, this is 0, and the future value here is just the amount, $11,000. Again, I added a negative sign in front of that. So that's down for the present value of $11,000 at year 1, and then add that the second present value, right? It's 21%, and this is at the year 6. So just put 6 there, and this is 0 for the payment, annuity payment, and then negative $55,000. Continue that. Present value again, PV again, and open 21%. And the last cash flow is year 10. So that's 10 and 0, and then negative $11,000. So that's gonna be I guess here I do need to worry about format because this is no longer this is actually in percentage terms and keeping 10 decimal places, which is not what we require. So we want to work with the numbers and then just keep 2 decimal places. So that's what I got. So, and then just copy that number back and check my answer again. All right, we're done.